we've got to separate these variables. So I'm going to cross multiply. dy is equal to x e to the y dx. I must separate my variables. So what should I do to separate the variables? Divide by e to the y, and I get 1 over e to the y dy is equal to x e to the x dx. Whoop, I'm sorry. I'm sorry. I'm a little tired. I got home last night at 9:30, and I graded those crappy tests till midnight. So. All right. I'm going to change this just a little bit. If it's e to the y on the bottom, I could write it as e to the negative y dy is equal to x dx. Now, I want to get rid of the dy, and I want to get rid of the dx. What do I do to get rid of those? Do integral. Okay? Does anybody know what the antiderivative of x is? I can't write small enough. I'm going to go down this space. So, what's the antiderivative of x? X squared over 2. What's the constant, right? Is equal to, what's the antiderivative of e to the y? E to the y. What's the antiderivative of e to the negative y? Negative e to the negative y. If you don't know how we did that, we actually set up substitution. We said u is equal to negative y, du is equal to negative dy. We had a negative du is equal to dy, and we solved it like that. So we did the substitution principle right there. Okay. So what variable do I want to solve for in order to find the general solution? I want to solve for y. How do I solve for y? What do I do to both sides? It'd be 4 natural log. The negative. So e to the negative y is equal to negative x squared over 2. I don't have to write minus c because it's still just a constant. So I could just write plus c. How do I get rid of the e? I natural log both sides. So I have e to the, the e goes away. I'm left with negative y is equal to the natural log of plus a constant. Good. Finally, I have to get rid of the negative, and I have y is equal to negative natural log of negative x squared over 2 plus a constant. That is what is referred to as the general solution, and it's general because it has a c value. We don't know what that constant value is. Right? We're going to do one more on this page to kind of tidy up things. We're going to try a little bit harder example. The one that says study guide is the study guide. This is just notes. Okay, so we're going to do problem 5. If you didn't leave room right here, then, or if you didn't leave room right here, you could put it over here. We're not going to do problem 6. Okay, so problem 5 is slightly more challenging. So I'm going to cross multiply. I get dy is equal to 2y minus 1 dx. Oh, I don't have any x's, do I? I just have y's. What should I do? How do I move it over? Divide. So you have 1 over 2y minus 1 dy is equal to dx. If you simply separate your variables on the free response section of the AP exam, if you just do that, that will get you points. Okay? That's good news. You can all do that, right? Separate our variables. So now what we have is we want to find the antiderivative of these pieces. So I got to get rid of the dx and the dy, so I integrate. Okay? What is the antiderivative of dx? There's just a 1 in front of it. So there's a 1 here. What's the antiderivative of 1? X, and then plus a constant. Now I have to come up with the antiderivative of 1 over 2y minus 1. What method do I have to use when I integrate here? Substitution. So I will go to a different page where I say 1 over 2y minus 1 dy. If I want to integrate that, I have to say u is equal to 2y minus 1. So what is du? 2 dy. Do I have a 2 dy? So 1 half du is equal to dy. So my new integral is 1 half times the integral of 1 over u du. What is the antiderivative of 1 over u? Natural log. My recommendation to you is this, and I apologize for anybody listening because I have not investigated far enough. But when you come up with natural log from an integral, the domain of a natural log function is just positive numbers. You can never have negative numbers inputted into a natural log. What do we do to make sure we don't have negative numbers? Absolute value. So if you pop up a natural log, just include absolute value. So we got 1 half times the natural log of the absolute value of 2y minus 1. It's one shot. Yeah. Okay, so I have my antiderivative. I'm going to put that right here. I've got 1 half times the natural log of 2y minus 1. In order to find my general solution, I have to solve for what variable? Y. How do I solve for y? What do I do both sides? Multiply by 2. So I got the natural log of the absolute value of 2y minus 1 is equal to 2x plus, we don't have to write 2c because it's still just a constant, right? Now what do I have to get rid of? So e. So that will go away, and I get 2y minus 1, take off the absolute values, is equal to e to the 2x plus c. Now here's where you're going to get angry at me, okay? But you gotta just trust that this is part of what you're going to need to learn. What would you do now to solve for y? And I don't know if they would give you entire credit for that. I think that they would. But that's not how they'll express the answer in the multiple choice section. Here's what they do. They pull a little trick. Watch. No, this is totally set up for what you're going to cover in differential equations. So they want you to see this so that you're prepared for your differential equations course today. So here's what they're going to do, okay? They're going to take this 2y minus 1, and they're going to write it as e to the 2x times e to a constant. So everybody see how I was able to make that step? All I used is this property. X to the 5th is the same thing as x to the 3 plus 2, right? It's the same thing as x to the 3rd times x squared. Those are equivalent, right? So look at what happened. E to the c is just some constant. So they would say 2y minus 1 is equal to some constant times e to the 2x. Some people use k, some people use a. Some people just use a big C still. And at this point, they will then add the 1 and divide by the 2 to get y equals k times e to the 2x plus 1 divided by 2. So I just want you guys to understand that they're not simply just going to leave the constant up in the exponent. That they won't do that, because there are applications where it's much easier to have the constant there. And we will look at one very shortly. All right? So this is the general solution. Let's go to an easier problem. Flip it over. They for sure do that. I mean, if you were to say that was the general solution, I think that they would give you credit. But without a doubt, in the multiple choice, they won't leave the C up in the exponent at all. Okay? All right. So this will be a nice introduction to our AP problems. We're just going to do 2 problems before the end of the day. We're going to look at problem 7 here, and then it's side problem 7. We're going to do 1 AP problem. Okay. You're going to practice one AP problem tonight. You're going to practice one tomorrow. Okay? And they're shorter. So hopefully it'll work out for you. All right. Here we have a differential equation of 2e to the x minus y, and it has what is referred to as an initial condition of y of 1 is equal to natural log of 2e plus 1. What that means is it has an xy coordinate that it passes through, and the xy coordinate is 1, and the y coordinate is the natural log of 2e plus 1. That's what that notation means. Okay? So this is the y value. The input is the x value. It says for each problem, find the particular. Particular solution means we will not have that constant in our answer. We'll be able to get rid of that. Okay? So it also says that we will want to sketch a graph. Okay? So I'm just going to pick a spot. I'm going to pick 0, 1. Does anybody think they could come up here and draw a sketch of the graph that would kind of follow the slope fields that would pass through that point? If you want to give it a shot, Colin, come on up. Let's give him a round of applause. He's showing a star quality of challenge. All right. If you want to try again, we will hit undo. Look around the point. Look around the point and look at how the slopes are. Kind of go forward and backwards from that point. See if it fits. Okay. Excellent. Okay. All right. Very nice job. Now, this part right here, would you agree that this kind of follows where the slopes are headed? But here, it seems like it's starting to go against the grain a little bit, doesn't it? They would actually want this side of the curve. You can see that it's kind of headed a little bit more like this. So what they would want here is they would want something a little bit like that. I guess that they might accept something that would look like, yeah, they might accept that. Yeah, you're right. I didn't look at it like that originally. They are pretty forgiving about these. If you look at the next one, if we were to plot 0, 1, does everybody see that the slope field would make this type of a shape? Okay, so drawing a curve that fits the slope field, you'll get a point just for doing that. In fact, I talked to Sam Ware today, and he said he remembered as he took the AP test last year. That's the only part he did on this free response question. He drew the slope field. That's all he knew how to do. So we really uncover these kind of questions. You're in better shape than he is. All right. So it says find the particular solution. I'm going to run out of room, so I'm going to put it on the next page. We are going to have 2e to the, is it x minus y? Okay, and that's dy over dx is equal to that. And then we have an initial condition of a x value of 1, and the y value is natural log of. Okay, so we want to find the particular solution. We will do the same thing that we did before. The only difference is we will then go back and use what's called a particular initial condition. Okay, so I'm going to rewrite this. Dy over dx is equal to 2e to the x times e to the what? Negative y. So we are doing this problem right here. I just don't have room to fit it there with what I'm going to write. So yep. So what I want to do is gather my x's and gather my y's. I will multiply both sides by dx. I get dy is equal to 2e to the x times e to the negative y dx. What do I have to move? E to the negative y. So I'll move e to the negative y. I'll divide. So dy over e to the negative y is equal to 2e to the x dx. Hey, I have e to the negative y in the denominator. What can I do to get rid of the negative? Yep, so I have e to the y dy is equal to 2e to the x dx. Now I've got my x's and my y's gathered on appropriate sides. What do I do to get rid of the dx and the dy? I integrate. As I integrate, what is the antiderivative of e to the y? E to the y. 2 is just a constant, comes along for the ride. So what's the integral of 2e to the x? Plus c. Oh, goodness. We talked about that yesterday. If you had, say, e to the y plus a constant, we'll call that constant 1 equals, say, 2e to the x plus a constant, we'll call that constant 2. You would just minus c sub 1 for both sides, right? And you get e to the y is equal to 2e to the x plus c sub 2 minus c sub 1. And isn't that just another constant? So as opposed to doing it on both sides, it's kind of redundant. Let's just include one with the x's. It doesn't, but I would put it with the x's. Okay, so let's plug in some pieces here. I now want to solve for c. So I will use my initial condition. I have e to the, what is my y value? Natural log of 2e plus 1 is equal to 2e to the, what is the x value? 1 plus a constant. I am trying to solve for c right now because this is the general solution. I'm trying to find the particular solution, the solution that matches the initial condition. What simplifies here? And I get 2e plus 1 is equal to 2e plus a constant. What is the constant value? It is 1. 2e plus 1 is equal to 2e plus c. What would c have to be to make that statement true? 1. Or you could subtract your 2e's from both sides. You would still get c is equal to 1. So I now have a solution for c. I have e to the y is equal to 2e to the x plus 1. No, we will solve for y, and that will be our particular solution. How do we solve for y? Natural log both sides, and I get y is equal to the natural log of 2e to the x plus 1. That's your particular solution. You now have enough, what? Yes, but when we do this on the AP exam, that part is 6 out of the 9 points. So we will try one problem when you get back, and leave you from there. Oh, you can lie. It's okay. All right, here we go. So we're just going to do the front part of number 1, and then we're going to move on to number 2. The rest of these I don't think are as indicative of what we need to learn for this section. So it says consider this differential equation 2x minus y, and on the axes provide a sketch of the slope field given this differential equation. So if I want to sketch the slope field, come on back. Here we go. What would the slope be at 0, 0? 0. So grab your AP packet I just handed to you. Did I not hand one's over there? Let's move to here, okay? Let's move to the point 0, 1. What is the slope going to be at 0, 1? negative 1. What is the slope going to be at 0, 2? Negative 2. What's the slope going to be at 0, negative 1? 1. What is the slope going to be at 1, negative 1? 3. What's the slope going to be at 1, 0? 2. What's the slope going to be at 1, 1? 1. And what's the slope going to be at 1, 2? 0. So it wants you to do it for, it says the 6 points indicated, and you can see the 6 points, so it doesn't actually ask for any points on the x-axis. I drew them anyway. But that would be, you know, I mean, we try to draw 3 to the best of our ability, but obviously the zeros are very important. The positive negatives are important. You can draw positive 1, negative 1, but that's our slope field, okay? So everybody should be able to get a point on the test for doing that, okay? So let's flip it over and look at another type of problem that we'll see all the way through, okay? Consider the differential equation dy over dx equal to 3 minus y cosine of x. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 0 is equal to 1. The function f is defined for all real numbers. It starts with question A that everybody should be able to get. A portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. So I will plot the point 0, 1. Right now, what I'd like you to do is, on your own, I'd like you to try to draw the solution or the curve that would fit that, okay? So see if you can draw a curve that would fit that solution set. Hopefully we have something that looks like that. Good job, you got a point. Way to go. Easy enough? So you guys understand, you understand a little bit now why I'm covering some of this information? It didn't take us very long to figure out how to score a point or two, right? And when you see the next question, you'll be like, oh, I could definitely get those points as well. You just have to understand the context of what they are asking. So part B says, write an equation for a line tangent to the solution curve in part A at the point 0, 1. Use the equation to approximate f of point 2. It says to write a what? Equation for line. So what do we write? What do we need? Slope and a point on a line. So what's our point on our line? 0, 1. This is tangent at that spot. How do we find slope? What tells us slope? Derivative tells us slope. Are we given the derivative function or the original function? We're given the derivative. So how will we determine the slope at the point 0, 1? Plug in what? 0 and 1. So in order to determine slope, we will take 3 minus y times the cosine of x, and we will type in what goes in for y? 1. So I get 2 times the cosine of 0. What's the cosine of 0? 1. And 1 times 2 is 2. So therefore, what will the equation for the line be? Got that? So the question is now, can we use that to approximate the value of f of 0.2? How do we approximate the value of f of 0.2? What would we plug in? 0.2 to what? For what? X. So f of 0.2 is approximately equal to what we get when we plug in 0.2 for x. What's 2 times 0.2? 0.4 plus 1? So 1.4 is the approximation. That's not bad, is it? Do you understand that what they're trying to have you think about is understand that this is the derivative. It tells you slope. They also want you to have an understanding of what a slope field is. And what we did is we came up with an equation for a line that was tangent, so we could approximate f of 0.2, and we got 1.4, which it looks like it kind of fits on the graph, doesn't it? So seems like we're doing a reasonable job here. Okay, so let's try the last part, and that would be part C. So does part C ask for the general solution or the particular solution? The particular solution requires us to use our initial condition. The problem has been very kind. They've stated the initial condition a number of times for us, okay? They want to make sure that you use that. So let us set it up. We have dy over dx is equal to 3 minus y times the cosine of x. What should I do first? Yep, pull them apart, cross multiply. So we will get dy over 3 minus y is equal to cosine of x dx. Everybody agreed with that? What I would like to do now is I would like to get rid of the dy and the dx. How do I do that? Integrate. I know the integral of cosine of x dx. That's easy. Sine of x. Plus c, you must have your constant there because we will use it in order to determine the particular solution. Okay? Now, dy over 3 minus y, what do I have to use to find the antiderivative? Substitution. U is equal to 3 minus y. So du is equal to negative dy. So multiply by negative du is equal to dy. So I have negative integral of 1 over u du. What's the antiderivative of 1 over u? Natural log. Natural log popped out of nowhere. So I'm going to include my absolute value sign of what? 3 minus y is equal to that sine of x plus a constant. Okay? So it is now time to solve for C. What is my initial condition? So 0, 1 is my initial condition. I want you guys to understand visually what we are doing right now. When we solved for the general solution and we left it at C, that meant that we could have been looking at this curve. Or we could have been looking at this curve. But because it passes through 0, 1, that will be the green curve. So we're solving for that curve. Do you see the difference? Antiderivative, because you come up with C, it doesn't tell you location. It tells you shape, it doesn't tell you location. The initial condition gives us that location. So let's solve for that. What do I plug in for y? 1. So I get negative natural log of the absolute value of 3 minus 1. 2 is equal to, what do I plug in for x? 0. What's the sign of 0? Oh no. What's the sign of 0? 0. All you have to do, you're trying to memorize it. Don't memorize it, folks. Think of the picture. What's that coordinate? That's 0 degrees. What's that coordinate? 1, 1, 0. Is sine the x value or the y value? It's the y value. That's why we get 0, okay? Don't try to memorize it. Think of the picture. Okay, so sine of x is 0, so we get c. Oh, hey, what's the value of c? Negative natural log of 2. So we have negative natural log of 3 minus y is equal to sine of x minus the natural log of dose. This will allow me to find the particular solution as opposed to the general solution. What do I need to get rid of? I'll get rid of the negative first, so I'll divide by a negative, and I get natural log of 3 minus y is equal to negative sine of x plus the natural log of 2. What do I need to get rid of now? How do I get rid of that? Create a base of e. Those go away, and I'm left with 3 minus y is equal to e to the negative sine of x, and I'm going to choose to write this differently. Instead of plus natural log of 2, I can write as times e to the natural log of 2. Oh, hey, what happens to e to the natural log of 2? It just becomes 2. So we have 3 minus y is equal to 2e to the negative sine of x. Now what? Minus 3, negative y is equal to 2e to the negative sine of x. Minus 3. Now what? Divide by negative 1. Y is equal to 3 minus 2e to the negative sine of x. And that is the curve that we have up here. This curve right here is y equals 3 minus e to the negative sine of x. You guys, your question. Later, thanks for coming on in. Oh, I'm sorry. I forgot to write the 2. Yep. So, you guys, we totally understand that, again, you have to reset kind of your expectations. A 45% score the 3 on the exam. So some people are like, boy, I couldn't get half of that. Well, if you do get half of that, you're doing pretty well. Let's see where they score the points. And I think you'll be pleasantly surprised and happy. Okay? Number 1, for that curve, you get 1 point for the solution of the curve. My guess is that yours is pretty similar. They're going to be pretty forgiving about the shape. Okay? So as long as you got some kind of cosine type graph, you're all right there. Well, let's talk about that, okay? Now, part B was when you had to write the equation for the line, correct? So you got 1 point for coming up with y equals 2x plus 1. Now, everybody could do this problem, but might you forget how to do it? I'll admit you might forget how to do it, but honestly, part B is very gettable points. Very gettable points. Then part C, you have dy over dx is equal to this. You get 1 point for the separation of variables, meaning dy over 3 minus y is equal to cosine of x dx. You guys can separate the variables, can't you? That's 1 point just for separating the variables. Second of all, the antiderivative, we're able to come up with the antiderivative being sine of x plus c. Well, that's a point. Everybody can get the antiderivative of cosine and sine. Well, no, you got the second point would be the antiderivative negative natural log of or 1 over 3 minus y. And some people might forget to do substitution. I get that. But yep, then it's 2 points. For including the constant of integration, meaning the c, and solving for it, getting the natural log of 2, you get a point there. For plugging in the initial condition of 0, 1, you get a point. And then finally solving for I, or y, which was the last part, which was the most complicated part, that would give you your final point. In my opinion, I think it's very reasonable to expect that everybody could get, number 1, the solution to the curve, number 2, a separation of variables, and 3, one of the antiderivatives, and 4, a constant of integration, meaning you write the plus c. I think 4 out of 9 is very reasonable there. 4 out of 9 is 44%. Am I off, or you guys think that that's? I think so. And so, what you guys need to do is, as I said before, part of what you have to learn in life is how to struggle through difficult material. We had that conversation. Problem 3, which is your next problem, it is problem 6 from 2013. That follows very similar to what you just had. So it just has parts A and B, total 9 points out of that. go ahead, practice that tomorrow. When we get to class tomorrow, we're going to go over this and score it. We'll go over another one, and I'll give you one for homework. Otherwise, all you need to work on is your study guide. Again, I stayed up till midnight last night grading the crappy tests. Tonight, I told you would have the answer key for the study guide by tomorrow, and I will stand by my word. I will, whatever time it is, I will stay up and make sure that that is ready to go. I'm going to try to, I want this to be educational as well. I'm going to try to grade you strictly as the AP is graded. And so that'll be no. So, but trust me, I think we all know that this study guide is, I mean, you're going to do it. I mean, this is the best way to prepare for the test, right? Without a doubt. Without a doubt. So, all right, good job today. Last day of instruction tomorrow for quite a while. When you build water bottle rockets, what do you need? A 2-liter and a 20-ounce. Next week, Friday. Yep, if you want to match bottles, go ahead. Well, you're going to be taking AP tests most of next week. You know what I mean? No, so we'll be spending some time in class being able to launch rockets. Raise your hand if you have an AP test either in Bio, Gov, or Econ. So Alex and I will hang out, and Emma, I guess. Okay. So, we didn't raise your hand. You're not listening.